Hi everyone, pleasure to be here. My title is I'm in your cloud, reading everyone's email, and we'll be talking about hacking Azure AD via Active Directory. Let's start with a little who am I? I'm Dirk-Jan. I live in the Netherlands. It's not that far from here, only five-ish hour drive. I work at Fox IT, and there I do a little bit mix of pen testing, red teaming, researching. Actually, before I worked there, I did some freelance web development. So from that, I kind of rolled into security. And in my free time, I like writing tools. Several listings here. They're all in Python. Today's stuff is not all in Python, so it's kind of new for me. But if you're pen testing Active Directory, you've probably at least heard of some of these tools. I also wrote a Python implementation of Bloodhound. And I also write blogs, and the most infamous one, I guess, was Priv Exchange, which was something I wrote in January. And honestly, I did not expect it to be that big when I thought of it while sitting in a ski lift in France and looking at my phone, reading an article, and being like, maybe this should work. And it kind of blew up bigger than I thought. I also have a Twitter. You can follow me there. I try to keep it limited to research and sharing cool stuff. So what about today? I have a couple of topics. First, I want to explain what exactly Azure AD is. Talk about integrating Azure AD with Active Directory. Have a look at which roles there are in Azure AD, administrator roles, limited privilege roles. And then we'll do some exploitation. So pwning the cloud, privilege escalation in the cloud, and last, abusing seamless single sign-on. Also in this presentation, me writing PowerShell and very bad C#. I will probably release some source code after this. It's very bad, but it does its job. So let's start with how it all started for me. It was last summer, and I was at a pen test, and the client had put some goals for us. And one of the goals was, okay, can you try to see if you can access the CEO's mailbox? The mailbox was in Office 365, and almost all of their users had multi-factor authentication enforced, and also the CEO wasn't really in the office, so we couldn't just try to compromise his workstation and go from there, but we still wanted access to that mailbox. But I didn't really know much about Office 365 or Azure AD, and I had a lot of questions, like there is Azure AD, Office 365, there's Active Directory, there are admins, and how are they all connected? Like, we all know that the domain admin has full control over Active Directory. But how does Active Directory link up with Azure AD? And how does Azure AD link with Active Directory? Are there things going both ways, or is it only one way? And what exactly does Azure Active Directory have to do with Office 365? Maybe this is very obvious for some of you, but I really started from zero and I really tried to understand all of this. And if we look at these links, what can an on-premise domain admin actually do in Azure AD or in Office 365? And even more interesting, if you can affect Azure AD on-premise via on-premise, do you need domain admin account, or can you do it with a limited account? These are kind of the questions I started out with. And before I go deep diving into it, I just like to share a bit of my research approach. So how I typically approach this is we have two different things. So we have on-premise Active Directory, and we have a part in Azure or Azure. Now, we assume that there's a security boundary between the two, because they both have like separate access controls, and it shouldn't mean that from one side you can very easily go over to the other side. But every security boundary, there has to be some integration or synchronization, and there's some information which flows from one side to the other side and back. And that information is has to be considered trusted at some point. So I really started looking at what information goes from on-premise to the cloud, what information goes back. And if you know what information is synced between the two, you can also start looking at, okay, who can influence this information? And if I make some changes on-premise, how is that influenced in the cloud, or the other way around? That's kind of how I try to approach this. So let's start with Azure AD. According to Wikipedia, Azure Active Directory, or Azure AD short, is Microsoft's cloud-based identity and access management service. And it's kind of confusing until I found this picture, which will be coming back a bit more in my presentation. So Azure AD is really like an identity platform. I always like to compare it like with Facebook. If you're developing a website, you can like integrate authentication with Facebook, and then you connect with your Facebook account to your website, and then you're logged in with your Facebook account. And Azure AD is a bit like that. It's really like a single source of authentication that is connected to Office 365, but also to the Azure applications. And even though it's called Active Directory, there are very little things that it have in common, actually almost no things. So on-premise Active Directory is now kind of referred to as Windows Server Active Directory in Microsoft documentation. And you see there are very different protocols in place. And it's really not something to compare. So Azure Active Directory definitely is not a domain controller in the cloud. There is some service for that, which again has a very similar naming scheme. So it's confusing, but we try to Active Directory on-premise and Azure Active Directory in the cloud. So if you want to integrate these two, there are three primary methods. You can use password hash synchronization, pass-through authentication, and Active Directory federation services. In this presentation, I'm only going to focus on the first one. It's the most common one, and it's also the one that they happen to be using at the client I was investigating it in. I haven't looked at the other ones yet, but there is some, I think, interesting research out there as well. So password hash synchronization. The principle is pretty simple, I think. The idea is that a user has a password in the on-premise directory, and there's a tool installed that just synchronizes the hashed password into Azure. And every time the user changes his password, that password gets uploaded, or kind of uploaded to the cloud, and the user can log in with the same password on-premise and in Office 365 or in Azure AD. So it's really synchronizing those hashed passwords. And the tool used for that is Azure AD Connect. This is installed on-premise, to install it on a server. And of course, it needs to have access to the hashed passwords that it needs to synchronize to Azure AD. So it's a very high privilege AD account. It also has a high privilege account in Azure AD, which makes it a very high value target, since it has high privileges both on-premise and in the cloud. And the TLDR kind of is, if you're using password hash synchronization, if your Azure AD sync account is compromised, then your Active Directory is also compromised. And we'll see a bit more about that in the next section. So how do we actually find where the Active Directory Connect tool is installed? Well, when you create it, a user gets created in Active Directory, which has the MSOL_ prefix, and it nicely mentions in the description on which server you're installing it. So if you look at this in LDAP, then you can just find, in most times, the server that is running on. So then you know on that server, if you compromise it, you very likely can compromise Active Directory as well. So I started looking a bit at how Azure AD Connect is configured. And the credentials are stored in the database. You can just find that in C program files. And there's a data directory. And you can browse that as a local DB via the MS SQL APIs, or you can copy it and browse it locally. And there are two interesting tables here. One is the MMS management agent and the server configuration. And I started looking a bit more at the data in these tables. So for the agent configuration, there's an XML containing part, and there's also an encrypted configuration. And if we look at the private configuration, we see the account name, we see our on-premise domain name, and we also see that the password is not there, but it has a field encrypted is 1. So it kind of suggests that the password is present in the encrypted data, which is also in the table. So I started digging a bit further, and all the crypto magic things that are happening in the DLL called mcrypt. And this is a mixed DLL, meaning it contains both C# and compiled C++ code. Now, C# is kind of easy to decompile, but the native code contains all the cryptographic functions. And since I'm not really good with IDA or reading assembly, I tried to do it a bit easier way. I first started looking at the C# code, and there's this function load keyset, which takes 3 parameters, 2 GUIDs and an integer for the keyset. And it suggests kind of that the keyset is the part containing the private keys. So it so happens that these fields are all in the server configuration table. So it's quite easy to find. So I wrote this very small proof of concept, which just imports the library, initializes a new key manager, and passes the correct parameters to it. Then I started Procmon and started looking at, okay, what is it actually doing? What is it querying? And it turns out that it's looking for data in the registry. And if you look on the right, you see that it queries for 514 bytes. And we'll see that a bit further. And since I didn't like to compile my proof of concept every time, then transfer it to the server, run it there, and debug it, I decided to copy over the registry keys to my local machine so I could see what happened. And that didn't really work out, because locally it gave an error all the time, while on the server it worked even with the same data present in the registry. So this suggests that it's using some kind of protection that depends on the machine. And some of you may know about DP API. It does exactly this. If you're coding, it's quite a simple API to use. You just use one line of code. You say, okay, encrypt this data for me, and then it's encrypted. And you can tie that either to the account that you're running under, or you can tie it to the machine. So how can we look what is going in and out of DP API? Well, we just monitor the calls to the DLL, and I use a program for that. It's called API Monitor. It's really nice. You can just find all the Windows DLLs, and you check the functions you want to monitor. And when you then run the proof of concept, we see one call to crypt unprotect data. And then we see 514 bytes going in. So that's exactly the 514 bytes that were pulled from the registry. This kind of suggests that it tries to read secret from the registry, then decrypts it using DP API, and then it has the encryption key set, as you can see on the right. Okay, then it passes it on to all the native code and does some more crypto magic, which you can also nicely monitor. We just monitor all the other Windows crypto APIs, and you can just see it's using AES in CBC mode. It gets an initialization vector from somewhere, and then decrypts the data. So the short version, the encryption key is encrypted with DP API. And if you decrypt that, there are some AES keys in the blob, which you can use for the AES 265 encryption in CBC mode. And then you get back your plain text passwords. So to summarize, there are 2 data sources here. One is the database, which contains encrypted data and entropy. And the other is the registry, which contains the encrypted private key. Now, I wrote a few tools to dump this and made a short video. So this is me remote desktoping to the server, which has the AD Connect utility installed. And let's see if this works. Yes. So I copy executable here that I created, and I run it, and it just creates some output. what the executable does, it just queries the locally installed database, and it extracts all the information that it needs from the tables. And then it writes that to a text file, which I can copy back to my attacks machine. And then there's a Python utility, because I'm very bad at C#, and it decrypts the XML data, and you see a lot of stuff, among which are 2 passwords, one for the on-premise account and one for the account in Azure AD. So this is nice, I guess, because you can run executable on the server, then gather all the data and decrypt it locally. I was like, okay, but in theory, all this information can be queried via the network. So I wrote another tool, also in Python, and it does it all remotely via RPC calls. So that saves you from actually running executables on the server. So what it does, first it stops the AD sync service, because it cannot access the database if it's in use by the servers. Then it downloads the database to the local computer. Then it looks up the DP API keys. There are some master keys stored on disk, and there are some keys which these keys are encrypted in the registry. And this is all based on secrets dump. So Albertus Lino did most of the work here with grabbing the keys from the LSA and decrypting those and getting those. And I just took the encrypted part, and you can look up with which key it was encrypted. You get that one from disk, and then you find the right key, you decrypt the right key, and then you can decrypt the data. So that's what happens here. Gets the encryption keys from the registry, gets the master key from disk, and then you decrypt the passwords. And then we have the sync account for Azure AD and also for the local directory. And if we have the sync account with the local directory, we can of course run DC sync and get all the hashes. So now, by compromising the Azure AD Connect server, either remotely or via running the executables, we get full control over the on-premise Active Directory. So, recommendation, do protect your Azure AD Connect server like it's a domain controller, because it has the same privileges as domain controllers. And if you're using the tiering model, which already came by in a couple of talks today, definitely put the Azure AD Connect in tier 0, because it basically has God mode in your Active Directory. All right, so that was one part. Let's look more at Azure AD and how all the things work there. So here's again this picture. And if you're talking about administrator roles in Azure AD, there are 2 different ways. One is the Azure AD administrator roles, which are used in Office 365, and one are the resource-based access control IAM solution, which is used for the Azure Resource Manager. So the part on the left is what you use to manage your Azure virtual machines and stuff, and the part on the right is Office 365. And it only uses those administrator roles, so not the RBAC roles. So if you're looking for documentation on this and you see RBAC in the title, you know it's not related to Office 365. Now there are a couple of ways to interact with Azure AD. I use 2 different PowerShell modules. One is called MS Online, and one is the Azure AD PowerShell module. They have different purposes and different features, and some things you can do with one but not with the other. And they also like to display different data while calling it the same thing, which is quite confusing, because on the screenshot here you see the roles, and in the above you see that there are only 5 roles in the Azure AD, and on the bottom one you see a lot of more roles, and they also have a different object ID, which is very confusing. It's all correct, by the way, they're just using different names for different things, or the same name for different things. So how can you query who the admins are in Azure AD? It's very easy to do this via the PowerShell modules, and anyone can query the members of any role, really similar to how any user in Active Directory can query all the groups and the members of these groups. And then we try to focus on the company administrator, or the global administrator as it's called in the Azure portal. And we see that here is one member, it's called Bob. And there are two kind of interesting parameters here. The first one is the last dir sync time. If that's empty, it means that this account only exists in Azure AD. It's not synchronized from on-premise to Azure AD. If there's a timestamp there, that means that it's synchronized from on-premise and the password is synchronized all the time to the cloud. Also, we can see the strong authentication requirements, which indicates if the user has multi-factor authentication enabled, but you can only query this as administrator. So it's not possible to do that from a regular user. So now let's look at cloud-only or synced accounts. In most of the setups, not all the admin accounts will be synced with on-premise directory. And anyone can see who are these admin accounts that are not synchronized. So the question is, if we are a domain admin, can we somehow link that cloud account to an existing on-premise account and that way take it over? And it turns out, yes, we can. So this is Office 365, and of course, if you have an account in the cloud with a mailbox, you may want to link that to an on-premise user after you've already created the users on both sides. And there's a thing called SMTP matching, and you can use that to match your on-premise users to the cloud users. So what are the requirements for that? You have to have an account with a proxy address, so with a mailbox assigned to it. It doesn't need to be a licensed Office 365 account, and it should not already be synced. So here I'm searching specifically for accounts that have this. We see the last dir sync time is empty, so it's a cloud-only account, and it has a proxy address. In the admin center, it appears like this. So the admin test account is in the cloud only. Now what we can do on-premise, we can create a new account which has SMTP address admin test at my Office 365 domain. And then somehow magically this account will start to get synced with the cloud. So the user we just created with a password that we know just got linked to the highest admin account on Office 365. And if you're this very high admin account, you can manage permissions on inboxes, for example. So let's assume that this is the CEO. He has a mailbox. Of course, people shouldn't be able to read it. But we are a global admin, and we can just assign ourselves privileges to read this mailbox. So in this assignment, we created a new account in Active Directory. We linked it to an existing admin account that they had. We delegated ourselves permissions to read the CEO's mailbox, and then we had our flag achieved. If you've been paying attention, you may see where this is going. You don't necessarily need domain admin to create new users. And if you're in a larger organization, a lot of your maybe junior IT admins have the task to create new users. So a lot of people have this privilege probably in larger organizations. And create user privileges was sufficient to take over the highest admin accounts. Of course, it should be noted that multi-factor authentication was not bypassed since you only control the password. So if there were any multi-factor settings required, you could still not log into the account. But not all companies have all admin accounts with multi-factor. It was even a recommendation from Microsoft up until a few months ago to have at least one admin account without any multi-factor authentication requirements. Because if multi-factor breaks, then you're locked out from your Office 365 environment and everything is screwed. So if you were following the recommendations and had an admin account without multi-factor excluded from conditional access, then anyone who could create a user could take over your admin accounts, which is pretty bad. They fixed this. So I reported this in June, and it was fixed in October. And right now it's not possible anymore to synchronize on-premise users to admin accounts. So that's good. Still, what we learned from this, do enforce multi-factor authentication for all accounts. And if you really cannot do it, you can enable monitoring. It does require a premium license. But you can create, for example, a rule that, okay, this is our emergency account. It should never sign in. If it does anyway, send an email to everyone. And this is an example from that kind of alert. So this was one part. Now we're going to look at privileges in the cloud. So we're forgetting on-premise for a bit and looking at role privileges in Azure AD. We have our global administrator that can do anything, but we also have limited administrator accounts. There are application administrators, authentication administrators, exchange administrators, and a couple of others. They have permissions, but they don't have all permissions like the global admins do. And these roles are fixed, so you cannot say, okay, I want the application administrator with just these few privileges removed or with just these privileges added. It's fixed. You either are a member of that role and you can do what is defined in that role, or you can't. These roles, privileges are pretty well documented online. I've included the URL here so you can have a look at it. And an interesting one are the application administrators, who can, quote, create and manage all aspects of enterprise applications, application registrations, and application proxy settings. I was wondering, okay, so what exactly is an application? Well, it turns out, everything. Some examples, the Microsoft Graph, the Azure portal itself is an application which is registered in your Azure AD. And if you use the default Office 365, there are about 200 pre-existing applications that have accounts in your Office 365 environment. Again, a confusing part, service principals versus applications. I actually revised this slide because when I wrote it first down, I was completely wrong. Then I went again about it, and I think it's now correct. So if you're talking about applications or application registrations, as they're called in the portal, these are applications that exist in your Azure AD specifically. So you can query them with PowerShell or with the Azure CLI. And you can just see they have an object ID, app ID, and a name. And then there are also service principals. So service principals are accounts in your Azure AD that either are linked to an application in your Azure AD or to a third-party application. So for example, Microsoft applications, they're not your applications, they're made by Microsoft, but you are using them in your Azure AD, so they have a service principal in your Azure AD. To make it more confusing, applications can have privileges. And there are two kinds of privileges an application can have. One is delegated permissions, and those are only active when a user is signed in and is actively using your applications. So then you can, for example, give an application the privilege to read the contact information of the signed-in user, to read his profile picture, name, and stuff. And you also have applications explicitly assigned to an application. These can be used at any time by the application and don't require a user to be logged in or a user to even know about your application. And these privileges are assigned to the service principal in your Azure AD. And for some of them, admin approval is needed. So here's an example. If you look, I made a new application, and I'm saying, okay, this application requires some permissions. It requires the permissions to read and write directory data in my Azure AD. Then on the service principal tab, we see that this application has these permissions, and also that an admin has to approve these permissions because they're very high permissions. They allow the application to read and write to all kinds of data in Azure AD. So here's one of the problems. By default, any user in Azure AD can create new applications. And they can also create service principals for these applications. So these are kind of accounts that the user can create which are assigned or connected to applications. This user will then be the owner of the application. So let's imagine that Bob registers an application, and that application needs to perform some task. It needs to read data or write data, and he asks the company admin, hey, can you give some application, can you give my application some permissions, because it needs this. So the admin consents to the application getting those permissions, and now Bob suddenly also has these permissions because he owns the application. What Bob can, for example, do is create a new certificate and assign that certificate to the service principal, after which he can log in with that certificate as being that service principal. So here we just use PowerShell to create a new certificate. We query for the service principal, which has the name test app, and then we assign a new credential to the application. Then we can log in with that certificate, being that application, and it says, okay, welcome. And because we gave that application permissions, it can now do stuff that Bob normally couldn't do. So let's see, with the privileges of Bob, you try to add a member to a group. And it says, okay, access denied, you don't have permissions to add users to a group because you're a regular user. However, if it logs in as the application, Bob suddenly has permissions to add users to groups because the application that Bob owns has these privileges. What's even more interesting is that if you look at the logging, the test app is written down as the one who made this modification. So if Bob registers an application and assigns a principal at point X, and long after all these logs have been forgotten or deleted, he suddenly starts to perform actions with that, there's not really a reliable way to trace that back to Bob because it's done by the application. Problem 2, the application administrator can manage all the applications in Azure AD. And there are some default service principals that actually have more rights than the application administrator has. So the application administrator can assign a credential to that application and then escalate their privileges and perform actions that weren't possible before. So this is how that worked, or used to work, which is, I guess, a spoiler, but you used to be able to just query the Microsoft Graph, get its object ID, and assign new passwords to the Microsoft Graph principal. Then you're connecting as the Microsoft Graph account to Azure AD, and you can do all kinds of stuff. Like here again, I'm adding a new user to a group, and that shows up in the logs as, hey, the Microsoft Graph just added a new user to this group. But this is also fixed. I reported this in August, and Microsoft fixed this in December. And currently, if you try to assign a credential to built-in applications that Microsoft considers high privilege, then you will get this error. It says, I'm not sure if it's readable, but you don't have access to add or remove credentials for the service principal associated with the reserved application. Also, they have documented this behavior. So before I reported this wasn't there. So the application administrator can possibly elevate privileges if there are applications that he has control over that have more rights than him. There are some risks remaining. So if you're a global admin or an application admin, you can assign privileges to applications, and that way you can also backdoor the applications. Because if you're admin once, you just assign a credential to the service principals who cannot actually not do multi-factor authentication, and nobody really looks at it because it's often not even visible. Because credentials assigned to Microsoft apps are not even visible in the Azure portal. So you really have to dig with the API and query all of those 200 plus applications to actually see if they have assigned credentials, which could potentially be a backdoor. If you are using custom applications, so not just the default Microsoft applications, and you give those high privileges, they're still not protected. It's only the default Microsoft ones which have these extra protection. If you create new service principals, assign them high privileges, the application administrator can still take them over. Once again, back to this picture. The Azure Resource Manager also uses Azure AD for its identity and access management. So if we have privileges in Azure AD to modify these applications, we can also potentially escalate to the Azure Resource Manager. Because it's possible to assign resource-based access controls to service principals, which can then be managed by application administrators, or also by the on-premise sync account, which password we just recovered previously in the talk. And some applications may need very high privileges in the resource manager. For example, if you're using Terraform to automatically create virtual machines and networks and stuff, this can run with a service principal, which the application administrator has control over, or whoever user created the service principal has control over. So the TLDR, anyone with control over service principals can create new credentials for these accounts and potentially escalate privileges. And the important takeaway here is, I think, look at your service principals, have a look which ones have credentials assigned, and look who own these service principals, because they have all the permissions that the service principals do. All right, so one last topic, seamless single sign-on. It's like magic. You don't have to do anything. You just use your computer and you get signed in everywhere. So seamless single sign-on, also known as let's port all of Kerberos' weaknesses to Azure, because it uses Kerberos. And the flow of this, it's Kerberos, so it's always going to be hard, but I'm trying to keep it simple. There's a user who wants to sign in into Azure Active Directory. So it sends a login request, and Azure Active Directory says, hey, you can log in with Kerberos if you want. So the client requests a service ticket at the domain controller, and it says, hey, I want to log in to Azure. The domain controller says, okay, sure, here's a service ticket, which the client can then give to Azure AD, and it will sign the user in automatically. That was the easy part. Now the technical part. If you use seamless single sign-on, it creates a new computer account called the Azure AD SSO account. And this password is the same in on-premise Active Directory and in Azure Active Directory. So if you get a service ticket for Azure Active Directory, it's encrypted with this password, because that's how service tickets work in Kerberos. And also this ticket contains your user security identifier, which uniquely identifies you in your domain. So if you present your service ticket to Azure, it can decrypt it so that it knows that whoever issued the ticket knew the password of the account, so it accepts it as valid. And then it looks up the security identifier in Azure AD. So if I have a ticket with like SID 1500 and I sign into Azure, it looks it up, oh, it's user 1500, okay, let's sign him in. And I'm logged in. But this introduces some risks. If your Active Directory is compromised, attackers can dump all the hashes, create golden tickets, silver tickets, all kinds of fake tickets, and that can be used to log in as any user in Azure AD if they don't have multi-factor authentication. Because seamless single sign-on is only a replacement for the password. It's not a second factor, it's only the first factor. Silver tickets are, I think, by now quite a well-known Kerberos risk, and this was documented like 1 month after this feature came out, so nothing new here. But there's more Kerberos stuff, and this is where it gets even more technical. I'll try to keep it short, because if I explain all of Kerberos, we'll still be standing here tomorrow, I think. So Kerberos has the concept of delegation, and delegation pretty much means trusting applications to impersonate other users. The use case of this is if a user connects to me as an application and I want to authenticate to other systems in the network, I need some kind of permission to say, hey, I'm this user. If this is configured incorrectly, however, applications can impersonate any user and potentially escalate privileges. There are 3 forms of delegation, which I'll go over very shortly. You have unconstrained delegation, which basically gives anyone that connects to your service. If I'm a service and I have unconstrained delegation permissions, anyone who connects to me gives me their tickets and I can impersonate them to any system in Active Directory. So it's pretty bad. Please avoid using that. There are a lot of blogs about this that you can read about. But unconstrained, try not to use. Constrained delegation has to be specifically configured. So unless someone was like, okay, I'm going to configure constrained delegation for someone to delegate tickets to Azure, which I don't think is a use case for, so it's not very likely this happens. But it's not really a likely attack vector for Azure AD. There's, however, a third one, which has recently been gaining some traction, which is called resource-based constrained delegation. Long words. What it means is the delegation is configured on the target object. So you have all kinds of objects in Active Directory, like users, computers, and if you can modify that object and say, okay, these users are allowed to delegate Kerberos tickets and thus impersonate any user while connecting to this service. The Azure AD SSO account is a computer account, which can be managed by a lot of people in the organization probably, because it doesn't have any special protections. So if you have permissions to manage computer accounts in the organizational unit or the container that this single sign-on account is in, you can assign delegation permissions for it. And I think it's quite likely in large organizations that quite some people have this privilege. Probably more people than they want managing all their Office 365. And of course, all this research is not just done by me, but by a lot of other people, also from several in this room, from Elad, Harmjoy, and Benjamin here. This is kind of new stuff. And I did some tools on this. So we're trying to configure the Kerberos delegation on this Azure SSO account. So this is a computer account, and I'm just running this tool, resource-based delegation.py. I have compromised the helpdesk user, which in this case has permissions to manage computer accounts. And Azure SSO account is one of these accounts that I can manage. So in the first part, it's modifying this account to allow the helpdesk user to create Kerberos tickets for this. And the second command, I query which permissions are assigned to that account, and it tells me, okay, so this security identifier is allowed to create Kerberos tickets for this account. What does this mean? I can create a Kerberos ticket for the auto logon service of Azure as while impersonating any user by being this helpdesk user. So I'm using a tool from Impact for this, and I'm here the helpdesk user in on-premise, and I'm saying, okay, I'm going to impersonate user Vince for the service autologon.microsoft Azure AD single sign-on. This works, so I'm getting a ticket, and this ticket is being saved locally. So now we go to Azure, and we say, okay, sign me in. And we get this nice few dots moving. And I'm intercepting a request here with burp. And what you see here is Kerberos authentication, which isn't really working because my Firefox didn't like the delegated ticket. But what you can do is create an authenticator from the ticket. So I use the ticket that we just created, which is valid for Vince. And I put the authenticator in the request. And then suddenly, I'm signed in as Vince on Azure. Am I Vince? No. I just am the guy who is allowed to manage the single sign-on account. The short version of this is anyone who can edit properties of the Azure AD single sign-on account can impersonate any user in Azure AD using Kerberos, as long as you're not using multi-factor authentication. So there is a little but in there. You also need to have control over one account with a service principal name set. But I don't think there's any case in which you will have privileges over the Azure AD single sign-on account, but don't have these other privileges. So basically, anyone who can edit this account can impersonate users in your Azure AD. Now we have Bloodhound and this very badly photoshopped screenshot. So you can actually detect this in the new Bloodhound. If you see the add allowed to act, which points to your Azure AD SSO account, then that account can impersonate users in Azure AD. I reported this to Microsoft in January, and the conclusion was, yeah, we don't see why people should delegate access to Azure AD, but we're not going to fix it for now. Like, okay. So this is still possible. And the conclusion, I think, from this is look at your single sign-on account and look at who has privileges over that account and protect it unless you like people impersonating other people in Azure AD. The general conclusions, MFA all the things. Really, many of these attacks did not work if you had multi-factor authentication enforced for these accounts. And also, if you're doing multi-factor authentication, of course, it's very useful to exclude some IPs, like your office network, because it's considered trusted, and you don't want people in your office to have to get their phone to authenticate every time. But do be careful with that. Also, have a look at which external IP address your guest network has. I've had several clients in which their guest network was also in the trusted IP range of Azure. So anyone with the guest password, which usually is like the company name, doesn't need multi-factor authentication to log in on Azure. And if a targeted attacker is targeting your organization, most likely they'll be able to get access to your guest network at some point. Again, protect your Azure AD sync servers like they are domain controllers, because they do have the same privileges. They can synchronize any hash of any user and do a lot of bad stuff. And audit your service principals, because they have access and people can manage their service principals and they potentially also have that access. And it's not always very visible who is allowed to do what. And this is my personal opinion, but if you're using single sign-on, it does weaken security unless you take care of your single sign-on account very much, but you still have those Kerberos weaknesses which are either well known or starting to be known, and it's just adding more risk to your integration with Active Directory and Azure AD. So thank you. This was my talk about this.